Okay, so for this next lesson, lesson 8, we want to look at graphing the reciprocal of quadratic functions, which really is very similar to the linear functions. We're just looking at an original function that is a quadratic instead of a linear. But all of the same rules will apply. So the first question here says, graph the reciprocal of a quadratic function. Consider f of x equals x squared minus 4. What is the reciprocal function of f of x? Well, that would be y equals 1 over x squared minus 4, but if we're looking at a reciprocal function, we can give that another name. We could call it something like, I don't know, h of x or k of x, okay, or r of x, right? The reciprocal function would be 1 over x squared minus 4. State the non-permissible values of x and the equations of the vertical asymptotes. So similar to linear functions, my non-permissible values, and here my non-permissible values, I know that x squared minus 4 cannot equal to 0, so x squared cannot equal to 4, so x cannot equal to plus or minus 2, plus or minus the square root of 4. Or I could also have factored that with a difference of squares, right? X minus 2, x plus 2 cannot equal to 0, so x cannot equal to plus or minus 2. Once I know my non-permissible values, those give me the equations, okay? The equations of the vertical asymptotes come from those non-permissible values. The equations are x equals 2 and x equals negative 2, okay? Those are the equations of the vertical asymptotes. What are the x-intercepts and the y-intercepts of the reciprocal function? Well, that's kind of a trick question. There are no x-intercepts, okay? There are none, because if we're on our x-axis, right, on the x-axis, y is equal to 0, and 1 over 0 is undefined, okay? Therefore, no x-intercepts. But the y-intercept, okay, for this particular function, if we look at y equals x squared minus 4, or f of x rather, let's call it what it was f of x, okay? F of 0 is 0 squared minus 4, so f of 0 equals negative 4. That's on our original function, okay? On our reciprocal function, I could either put that in here, let me just make those zeros nicer. If I wanted to find the reciprocal value, I could say r of 0 is 1 over 0 squared minus 4, which is 1 over negative 4. So where our first function had a y-intercept of 0, 4, our reciprocal function was 1 over negative 4. So negative 4 became the reciprocal, negative 1/4. So I didn't necessarily have to do the math there. I could have just jumped right to the conclusion that my original was negative 4, my reciprocal is going to be negative 1 over 4. Because of course the 0 does not change, it's just the y coordinate. Okay, what are the coordinates of the vertex of f of x? Coordinates of this vertex, if we think back to y equals a, x minus p squared plus q, and we've got here, I guess we've got f of x equals x squared minus 4. Here we can recognize that our p value is 0 and our q value is negative 4, so our vertex is 0, negative 4. Determine the invariant points with your calculator. We'll just do that without our calculators here. I know that the invariant points are going to be at y equals 1 and y equals negative 1. So what I'm going to do is I'm going to plug that into, I could use either equation, but I'm going to use the first equation, okay? So if f of x equals 1, then I'm going to get 1 is equal to x squared minus 4. So x squared is equal to 5 when I move over the minus 4, and x is plus or minus root 5. Okay, and I know if f of x is equal to negative 1, then negative 1 is equal to x squared minus 4. And therefore 3 would be equal to x squared, and x would equal to plus or minus the square root Okay, so now if I'm looking for the domain of the reciprocal function, I know that from up above, my non-permissible values, that x cannot equal to plus or minus 2, so that would in fact be my domain, set of all x such that x cannot equal to plus or minus 2. And then graph the function of y equals f of x and its reciprocal function. So I guess they're calling that g of x, which I called it r of x, but same thing. So we could go back here and change this to g of x. Okay, let's graph y equals x squared minus 4. I know my vertex is 0, negative 4. And I go over 1, up 1, over 2, up 4. And when we graph this, there's our original function f of x. And now I know that my x cannot equal to plus or minus 2 because of course that is where my asymptotes are, and those are the x-intercepts, okay, of, and let's just do that in dotted lines here. My x-intercepts are, in fact, x is equal to 2 and x is equal to negative 2. Those are our x-intercepts, and those are also the equations of our asymptotes. And I also know a couple things here. I know that my invariant points are at 1 and negative 1, where y is 1 and y is equal to negative 1. So I scooch horizontally across this imaginary line where y is equal to 1 right here until I find the two intersection points, okay? And now I even actually know what those values are because we just calculated them. When y is 1, or the value of my function is 1, x is plus or minus root 5. So this one here, this point here would actually be root 5 comma 1. Okay, and this point over here would be negative root 5 comma 1. And this point down here is root 3 comma negative 1 and negative root 3 comma negative 1. Okay, and we could have put that in our graphing calculator as well and just put a y1 and a y equals 1 and y equals negative 1 and found those intersection points, but we just did it algebraically. Now, when I look at each branch, this branch here is very similar to just a straight linear function. Okay, I'm going to take, and where I see little y values between 0 and 1, the reciprocal of those little y values is big y values. So I'm going to draw my graph going down. It goes up to infinity, comes down, it goes through that invariant point. Okay, and I could pick a few points here. Right here, y is 2, the reciprocal of 2 is 1/2. Okay, and then reciprocal of 3 would be 1/3, and so on. The reciprocal of big numbers becomes little numbers. Okay, so there's one branch of my reciprocal function. The other branch would be up here. On our left. And then this middle branch, what to do with our middle branch? The middle branch, let's take individual points. Again, these are little y values. The reciprocal of little y values are big y values. So for example, if I take a point here, right here, I'm just going to put a little, let's do it in green here. Okay, there's a little green point there. I'm going to tell you that that value is 1/8. Okay, negative 1/8. So the reciprocal of negative 1/8 is 8/1, negative 8/1. So I'm just going to, whoops, let's undo that. Okay, that negative 1/8 is going to move down here to negative 8. Okay, if I've got a point here of like, negative 1/2, right here, reciprocal of negative 1/2 is negative 2, and so on. So my graph, all the way until I get to 1, because the reciprocal of negative 1 is negative 1, it's going to intersect right there, so in black. And then I know my highest point here, this little vertex here, was 0, negative 4. 0, negative 4 is going to become 0, negative 1/4. So right here, 0, negative 1/4 is sort of my new vertex. Okay, when x is 0, y is negative 1/4. And then this is going to mirror on the other side. Reciprocals of little numbers will become big numbers out on the outer branch. And there is our reciprocal function drawn. Okay? Now, the next one says your turn. So I would recommend that you pause the video and try this yourself. Before you do that, I would do this. I would first factor, find the x-intercepts, draw the original function. So let's factor, find the x and y-intercepts. Once you know the x-intercepts, you can find the asymptotes of the original function. You can then, once you've found the asymptotes, you can find the y equals plus or minus 1, the invariant points. Okay, and then you can sketch. So pause the video, draw your original function, and then try drawing the reciprocal function. Okay, and state the domain. So pause the video and let's give that a try. Go on. Okay, so hopefully at this point you can do a minimum of finding the y-intercept, finding the vertex, and finding the x-intercepts. So the y-intercept is the constant. That's pretty straightforward, -6. To find the x-intercepts, of course, we have to factor, which I've done, and I found that x equals -3 and x equals 2. So I plotted those points. And then to find the vertex, what I use, instead of completing the square, I used the idea that my axis of symmetry, right, the equation of the axis of symmetry for this graph would be right here through the middle of my two x-intercepts at x is equal to -1/2. Okay, that would be the equation of the axis of symmetry. So I know that's my p-value as well. -3 plus 2 divided by 2, my p-value would be -1/2. Then I plugged that into my original equation, right? If I know if x is -1/2, that's going to be part of my vertex. What is my y-coordinate going to be? So I just went through and I solved that here, and I got -25/4. I could also have taken x is the p-value or the x-coordinate of my vertex, and I could have said y, or the q-coordinate of the vertex, would be -1/2 plus 3 times -1/2 minus 2. Okay, and now if I just wanted to add those, I would get -1/2 plus 3/2 and -1/2 minus 4/2, which would be 2/2 times -5/2. Oh, oops, this is not giving me the same answer. What have I done here? -10/4. Oh, I know what I did. This is, of course, silly. Okay, so this should be over 1. So this is times by 2 and times by 2. That should be 6/2. Okay, sorry about that. So that's going to be 5/2 times -5/2, which is -25/4. Okay, so of course we should get the same. Either way, this is the same equation factored, right? So I can plug that into there, or I can plug my -1/2 into my original equation. Either way, I get my vertex of -1/2, -6.25, or -25/4. I've plotted my original parabola. That's all I've done thus far. Now, in order to plot or sketch the reciprocal function, the first thing I want to do is find my x-intercepts. My x-intercepts are right there in front of me at x equals 2 and x equals -3. So let's draw that. And I'm just going to label those. X is equal to 2, x is equal to -3. Okay, these are the asymptotes right here. And then next step I'm going to do is I'm going to find my y values, where y is equal to 1 or y is equal to -1. Right, these are my invariant points. I'm actually going to have 4 invariant points for this graph, aren't I? Okay, 4 of them. And now, you know what I might do here, just to make this, I mean, it's really tricky to draw this so that you have room along the asymptote to draw. Okay, but now here are my invariant points, 1, 2, 3, 4, because the slope is kind of funny. And the reciprocal of -25/4, the reciprocal of my new function, the reciprocal would be -4/25. Very small number, 0.16, -0.16, okay? And that would be my new sort of maximum here, okay? And my invariant points are, of course, here and here, and so my graph, okay, the reciprocal of all these numbers between 1, -1 and -6.25 would become bigger numbers, and then these little numbers between 0 and 1 become bigger numbers. So there is our reciprocal function in the middle, and then these guys are just very similar to the linear idea. And same thing, but a symmetrical branch on the other side. Okay, and there is our reciprocal function. It also asks for the domain, and I know that the domain is comes from our asymptotes. Those are our non-permissible values. So our domain, we could say the domain set of all x such that x cannot equal to -3 and 2, but it's all other real numbers. So there's our domain. Okay, and I realize if you're following along at home, we have different notes, and I think that I changed this last year, but I forgot to update my PDF. So your question should say graph y equals x² plus 1, then graph the reciprocal function. Okay, then graph the reciprocal, and label the x and y intercepts. Okay, state the domain and range of both functions. So, of both functions. Okay, so let's start with y equals x² plus 1. I know that y equals x² plus 1 has a vertex of 0, 1. So I'm going to start with that. I also know my a value is +1, so this is an upward facing parabola going over 1, up 1, over 2, up 4, and so on, over 3, up 9. And there I go. There's my starting parabola, our initial function. Okay, the next thing I want to do when I graph my reciprocal function is, of course, I want to find my x-intercepts to find my vertical asymptotes. Well, there are no x-intercepts, therefore there are no vertical asymptotes. Okay, there's no non-permissible values here. If I look at the equation y equals 1 over x² plus 1, right? Because no matter what goes in for x, if I square that, and then add 1, this will never be equal to 0. In fact, if we try to solve for the non-permissible values, okay, we're going to get x squared plus 1 can't equal to 0. So x squared can't equal to negative 1. Well, in fact, if I take the square root, that's not possible, right? Not possible. So it's mathematically not possible because there are no non-permissible values. Because if we think about it, there's nothing that I can put in here that would make this a negative 1. Because the only thing that could add to 1 would be 0. It would be negative 1 to make it 0, right? But there's nothing that I can put in for x that would make that a negative 1, okay? It's not possible. So this one just requires a little bit extra analysis. So when I look at this right away, I notice there's no x-intercepts, so there are no vertical asymptotes. The next thing I want to do is I want to find if I have any invariant points. Well, if I zip along the equation or the line y equals 1, there is one invariant point just at the very bottom of the original parabola at the point 0, 1. Well, now if I want to think about all of my reciprocals, well, the reciprocal of 1 is 1, so that's why, of course, that's an invariant point. And then let's look at the corresponding values here. This value here, right up here, this was a value of 2, this was a value of 5, this was a value of 10. So the reciprocal of 2 would be 1/2. The reciprocal of 5 would be 1/5, getting a little bit closer to that x-axis. And the reciprocal of 10 would be 1/10. And if this graph went up to like a bazillion, the reciprocal of a bazillion would be 1/1 bazillionth. So of course this graph kind of looks like this. My reciprocal function. And it's going to be the same thing on the other side. And it looks something like that. Probably my left-hand one is a little bit. There we go. Okay, there is our reciprocal function. And now it also, I guess it goes without saying that we have a horizontal asymptote here at y is equal to 0, okay? Horizontal asymptote, HA, at y is equal to 0. If I'm looking for the domain and range of both functions, then I know that my domain for my original function and my range for my original function would be the set of all x such that x is all reals, and my range, the set of all y's such that y is greater than or equal to 1. For my reciprocal function, 1/f of x, my domain is still the set of all x such that x is all reals. Of course, our domain will never change, right? Our inputs aren't changing, it's just the y values. And our range for y equals 1/f of x is set of all y's such that my lowest y value is 0, my y's value is 1, the highest y value is 1. And if I take a look at that, I also note that I'll never equal to 0, okay? It's between 0 and 1, but it'll never equal 0. So we would say between 0 and 1, but it'll never equal to 0. So there's our range, and there's our domain. Okay, so hopefully that explains a little bit further about reciprocal functions of parabolas. This example down here says graph y equals f of x given the graph of the reciprocal function y equals 1/f of x. I'm going to graph the original function. The graph of the reciprocal function is given where a and b are non-zero constants that is shown below. So y equals ax plus b. Non-zero constants meaning this was some kind of a linear function. Sketch the graph of the original function y equals f of x and determine the graph of the original function. If I wanted to sketch the graph of the original function, I instantly know that I had an x-intercept here at 2, okay? Where I have an asymptote at x is equal to 2, Therefore, I had an x-intercept on f of x, our original function. And I also know I have a point 3 1/3. Therefore, I have a point 3 on f of x. Okay, our original function, because of course the reciprocal of 1/3 is 3. So I know I had a point up here at 3, 3. So I know a few things. I know this was linear. I have an x-intercept. I have another point. I can now figure out my slope, which is over 3 up 3 over 1, I should say. And if I want to keep going with that, down 3, left 1, down 3, left 1, I know that my y-intercept now is -6. So my line would look like this. And I know that the equation of that line would have been y is equal to 3x minus 6. Y is equal to 3x minus 6. So there's the first one. The next one is a your turn. If you'd like to pause the video now and give that a try, that would be awesome.